Good morning, students. Myself, Dr. Yogesh Pating, Assistant Professor in Commerce, GS College of Commerce, Parda. We are at unit number 3, Skewness, and I just explained you in last lecture about Carl Pearson's coefficient of skewness, the first method that we had in our syllabus. The third unit, as I already interacted with you that there are 3 methods. One is Carl Pearson's coefficient of skewness, the second one Bowley's coefficient of skewness, and the third one is Cayley's coefficient of skewness. In our syllabus we have to see 2 methods, the first Carl Pearson's coefficient of skewness and the second one is Bowley's coefficient of skewness. We already finished Carl Pearson's method in last 3 lectures. We allotted each and a separate lecture for each and every method for each and every series. So individual series, discrete series and continuous series. We already completed the problems, finished the problems of Carl Pearson's coefficient of skewness, the part of unit number 3, skewness. Today we will go through Bowley's coefficient of skewness, the second method. Before starting the problem, we will see the formula and we will see the logic behind that. In this first lecture of this particular method, we will see the problem of individual series, then we will have a separate lecture for a discrete series, and then the last lecture of unit number 3 will be again a separate lecture for a continuous series. Okay, so we will start the Bowley's coefficient of skewness. In this method of measuring skewness, the whole of this series is needed. Bowley has suggested a formula based on relative position of quartiles, so we just have to use quartiles here. In last coefficient of skewness, we use mean, mode and standard deviation. In Bowley's coefficient of skewness, we are using quartiles and median. In a symmetrical distribution, the quartiles are equidistant from the value of the mean. Median, that is median minus Q1 equals to Q3 minus median. This means the value of the median is mean of Q1 and Q3. But in a skewed distribution, the quartiles will not be equidistant from the median. Hence, Bowley has suggested following formula. There are 2 different formulas that are being suggested by Bowley. One is absolute skewness, that is Q3 plus Q1 minus 2 median. Other formula that we are going to use is Bowley's coefficient of skewness, that is Q3 plus Q1. Q3 means third quartile plus Q1 means first quartile minus 2 median divided by Q3 minus Q1. So the basic requirement of Bowley's coefficient of skewness was is we have first calculate first quartile, we have to calculate third quartile, and we have to calculate median also. So we have to calculate Q1, Q3 and median. That will be for us to solve the problem of Bowley's coefficient of skewness. So just making the what we can say what we needed for Carl Pearson's coefficient of skewness, we needed mean, we needed mode and standard deviation. That was a part of Carl Pearson's. In Bowley's coefficient of skewness, we need Q1, the first quartile, we need the Q3, third quartile, and we need the median. So when you are solving the problems in statistics, the most important thing is that you should first concentrate on the formulas that you are using, because as per the formula, your working will get shaped, your working will get that way. You have to prepare your need, and after getting all those figures or the items you need for your formula, then you will just get answer as per the formula. So this is the way we need to solve the problems of statistics. So the first problem, find out Bowley's coefficient of skewness from the given data 50, 120, 220, 170, 90, 40 and 10. But the most important thing is that there is an involvement of median. So when there will be a median, you have to arrange your data. So at the first thing that we did here is we arranged the data in ascending order. So it will be 10, then it will be 40, then 50, then 90, then 120 to then 170 and then 220. So the data is being arranged in ascending order. Why? Because median is there. That's why the data need to be arranged in ascending order. If you forget this, then the problem will completely get wrong. So when there will be a median, then the first thing you should keep in your mind is that the data need to be arranged in ascending order. Now we have to calculate Q1. Q1 equals to the size of n plus 1 upon 4th atom. Let me underline this thing first, because this is a method that we need to solve. Okay, Q1 equals to the size of n plus 1 upon 4th atom. The size of n equals to 7. Number of items is 7. 7 plus 1, 4th atom. The size of 8 divided by 4th atom. The size of second atom. The second item is 40. So Q1 equals to 40. So I hope you understand this thing very well. We will move to the next page. In between they solve the median. We will first see the Q3. The Q3 equals to size of 3 n by 1 4th atom. The size of 3 7 plus 1 upon 4th atom. The size of 3 8 by 4th atom. The size of 3 in bracket 2th atom. The size of 6th atom. We will go first previous page. The 6th item is 1 2 3 4 5 6. It is 170. So Q3 equals to 170. So we have Q1 now. We have Q3. Now it's a turn of median. M equals to size of n plus 1 upon 2th item. The formula of median for individual series. The size of 7 plus 1 upon 2th item. The size of 8 by 2th item. The size of 4th item. Now size of 4th item is 1 2 3 4. This one 90. The size of 4th item is 90. So M equals to 90. So now we have all those three requirements which we are going to use in our formula. We have Q1. Let us find what is Q1. Q1 equals to 40. We have Q3 170 and we have median 90. Now we will just put up the things in our formula. Sorry. Coefficient of skewness equals to, it is again denoted by J. Q3 plus Q1 minus 2m divided by Q3 minus Q1. We will put up the figures in said formula. Q3 170 plus Q1 40. Let me check it again. Yes, Q1 40 minus 2 in bracket m 90 bracket complete divided by 170 minus 40. So it will be 210. 170 plus 40, 210 minus 2 into 90 will be 180 divided by 170 minus 40, 130. 210 minus 180, 30. 30 divided by 130 equals to 0.23. As there is only there is no negative relationship there, so it is a positive coefficient of skewness. So this is a very simple problem of individual series, and actually the problems are very simple of coefficient of skewness. Summing up all this problem, what we did here, as per our requirement of coefficient of skewness, Euler's coefficient of skewness, we need first quartile, we need third quartile, we need median, and all those things, these three things, when we calculated, we can use a formula of coefficient of skewness and we will have the answer. So I hope you understand Bowley's coefficient of skewness, individual series problem very well. Once again I am repeating the formula. Q3 plus Q1 minus 2 median divided by Q3 minus Q1. So this is a problem of individual series. As I told you earlier that I distributed the lectures especially of Bowley's coefficient of skewness in three lectures. The first lecture is devoted for individual series, the second for discrete series, and the third, the last lecture of our unit number 3 is of continuous series. So we just finished the Bowley's coefficient of skewness, the second method of unit number 3, skewness of individual series. So I hope you understand this problem very well, the concept behind Bowley's coefficient of skewness and the problem of individual series. In next lecture we will see the problem of on a discrete series of Bowley's coefficient of skewness. There will be no change in that, but only as the series will get changed. In place of individual series, the discrete series will be there. So next lecture we will see a problem on Bowley's coefficient of skewness on a discrete series. So I hope you understand this problem very well. Next lecture we will meet for another problem. Thank you very much.